Hello, today I'm going to show you the NLP Text Analytics app built for use with Splunk. This app was built as a project for Regis University Data Science Practicum. The concept of this app is to allow Splunk to use natural language processing libraries and algorithms to take free-form text and process it, then return analysis of the text in various ways. This app tends to follow the life cycle of a data science project. The question and the data gathering is generally selected by what is already in Splunk and then searched on, or perhaps new data needs to be added to Splunk. Once that step is complete, the data will then need to be cleaned. In case you don't yet have some text to analyze, the app currently comes with 3 books from the Gutenberg project that have been reformatted into a CSV and can be loaded using the input lookup command. This app provides the clean text command for, cleaning text, as well as adding some NLP specific options. Some tasks it performs can be done in Splunk natively, but the command streamlines the process, though it has options to turn specifics on and off. The options include tokenizing and normalizing case, removing URLs, punctuation, and numbers, changing words to their base form using either lemmatization, which will retain a dictionary word, or stemming using the Porter stemming algorithm. This does not always result in a dictionary word. The command also optionally returns some metadata fields that can be used for further analysis. This includes part-of-speech tagging, such as whether a word is a noun, a verb, an adjective, etc., and engrams can also be returned from the text. These are word sequence combinations like quick brown fox. The app has even more options. Please see the documentation for complete details. Here is an example of the command's output using a few non-default options. Note that working with text can be time-consuming. Response times will be dependent on the amount of text used. Another cleaning tool the app provides is called BS4. This is a wrapper for some of the functionality from a Python package called Beautiful Soup 4. The primary use case in this app for the command is removing HTML formatting. However, it can also traverse a DOM tree extremely well, even from poorly formatted documents, and collect the text. This command is worthy of an app all to itself. You should run this command before the clean text command, as clean text by default will remove punctuation and render it useless. A simple example of the output from the command. By default, it removes all markup and returns the text in a new field called getText. Or as mentioned previously, it can traverse a DOM tree and retrieve text. In this case, just the bold text was the target. Also notice the badly formatted document with text preceding the tree. On a side note, the user is dropped off at a welcome screen. The welcome screen of the app provides some basic terminology in case the user is brand new to text analytics. This is followed by a list of required apps from Splunkbase for the app to work properly. The links will take you where you need to go. Then you will find brief explanations and syntax of each custom command, as well as the additional sklearn algorithms included in the app. The next phase of the lifecycle is exploratory data analysis. The counts dashboard fulfills the exploration into the text. The user is offered a series of input options for exploring the text, including the use of engrams and an optional grouping field. Looking at the book Moby Dick, we see that the totals return offer some basic concepts of scope. What stands out here is quite a few chapters and a very large vocabulary, as seen by the unique term count. Moving down and looking at the top terms, unsurprisingly, whale is the top word, but it is interesting, in the engram top counts, there are 3 different versions for whale in the top 10. Looking at the part of speech tagging, Herman Melville uses a lot of adjectives and adverbs denoted by JJ and RB. This may account for the large vocabulary, as verbs don't make the top count until the 6th ranking. Panels with the plus symbol have additional actions. Clicking on nouns, we can see an explanation of the tag and their individualized counts. Similarly, clicking on a top term will show examples of where it is used in the text. Clicking on the new windows will close them. When using the grouping field option, top terms can be seen per that group by selecting one. And again, we can select one to see it in the corpus. At the very bottom, we have word cloud visualizations. You can select the number of terms to show in the cloud. Optionally, if you selected the n-grams, you can view the n-gram cloud. A term might catch your eye in the word cloud that you might be less likely to notice in a table. For the JIRA support tickets, to create an input, I merged two fields together, summary and description, using Splunk's concatenation option in eval, and then table it out as the dashboard expects a tabular input. I also add the categories field to group by. Looking at the resulting set, certainly a smaller vocabulary, but a polite group since please is the top word, though we see other nuggets of information in the words email, access, and password. The top n-grams too provide some valuable insights regarding home directory and email group. The POS tags in this case are not so valuable, as the majority are nouns, plural and singular. I believe what is going on here is that the tickets do not necessitate proper grammar. This might be seen in the average of 18 terms per document, and the default of the POS tagger is to assume noun. However, moving down to the groups and viewing the permissions category, we see directory access type words appropriately. And installs are probably about software installs. However, there is an other group that is of interest. Seeing this in the data creates a good opportunity for unsupervised learning, specifically clustering, as one would expect other to be a dumping ground of tickets that don't fall into any other category. And just for good posture, we take a look at the word clouds. Back to our life cycle, we left off on exploration, with the remaining steps being about choosing features, making a model, and then communicating the model. All three of these happen together in the Themes dashboard. The inputs to the dashboard are numerous as it guides the user through the machine learning process. Notice I narrow my search now to only include categories that are other, and I am removing HTML formatting as some tickets come from HTML emails. Each step of the process has its own row of options. TF-IDF stands for Term Frequency Inverse Document Frequency, and is a process of essentially turning words into number representations. Normally, these are very large sparse matrices, so you can change the max features to a more manageable number. Also note, you might have to edit your ml.spl.conf file if you run into limits that you want to increase. Topic modeling can be turned off. It is about changing the large TF-IDF sparse matrix down to a smaller set of representative features. Clicking on the drop-down shows the 3 topic modeling algorithms packaged with this app that come from sklearn. Truncated SVD is also known as latent semantic analysis. Finally, you have the option of selecting any of the ML Toolkit clustering algorithms. K-means, Birch, and spectral clustering will accept a value for the number of clusters you want, while dbScan and xmeans will discover the number of clusters. While all these algorithms are offered to do clustering with, some you may find do not work very well with text clustering. In this case, I will use xmeans, which is actually k-means, but is using Bayesian information criterion scores to determine the clusters. Exploring the clusters created using xmeans, we see the algorithm decided on 46 clusters. The first visualization is just a list of the top terms per cluster. We can sort the clusters by their size and see how well dispersed they are. Clusters with a lot of values might be a catch-all cluster, or may be reason for creating another category because of document quantity. Bringing back more terms may help to get a better understanding of the clusters. Here the top cluster might be about intelligence reporting, though too many terms can make later visualizations convoluted. The next viz charts out the quantity of top terms by cluster. The top cluster was number 11, though my eye is also drawn to cluster 18. The values here seem to correspond to desk moving requests. The final visualization is truly a fun way to view clusters. By hovering over a single term, you can see all the clusters it is currently a part of. Likewise, you can do the same for a cluster and see where its terms overlap other clusters. I also ran xmeans on a sample of Moby Dick, Peter Pan, and Pride and Prejudice. The top cluster is probably a catch-all in this case, though in each cluster we can see remnants of the separate titles. I have chosen 5 terms for visual clarity. Looking at the top cluster, number 3, we can see how even its word counts look different from the other clusters. Finally, on the force-directed viz again, we can explore some clusters. This one seems like Peter Pan. And the word say, which again is lemmatized, is unsurprisingly used heavily, given that all the books are told in third-person narrative. The last piece of this app is something in text analytics that sits sometimes on the outside of the lifecycle and can be an end in itself, which is sentiment analysis, though it can also be part of the lifecycle as well. It can be used as part of exploratory data analysis, or creating new features for an ML model, or it might even help to define a problem in the first place. Some sentiment analysis engines or even machine learning models themselves. This app provides another custom command called Vader. This is based on a portion of the NLTK library of the same name. Vader stands for Valence Aware Dictionary and Sentiment Reasoner. Rather than being ML-based, it is rule-based. You should feed this command raw text, meaning it should include case, punctuation, and stop words, as it takes those into account to determine the overall sentiment. Built on the Vader command is the last dashboard called Sentiment. The inputs are rather straightforward, with the neutral zone size for the visualizations being the only customization. The Vader command gives out an overall or compound score that we can see visualized. Nice to see support tickets actually being positive. This may result back to the original finding that please is the top word, which no doubt contributes to this. The bar and line graph help to show the average sentiment over the lifespan of the corpus, and is plotting the output scores from the command minus the neutral scores. The sample ratio can be changed to show more or less data. Changing to 1% can act as a sort of zoom in on the data. But bringing in too much can make the graph unreadable. Luckily, however, hovering over the values in the legend can isolate the respective values. Below this, we have the neutral scores from Vader and their average. Here we see a majority of close to neutral values. The last visualization is interesting. Scores with high sentiment have near 0 negative scores and near 1 neutral scores, while scores with low sentiment have positive scores near 0, though they're neutral also approaching 1 rather than not. Finally, scores near the middle seem to overall have no negative or positive sentiment. This visualization can help with seeing why overall sentiment scored as it did, and may reinforce the thought that support tickets do not necessarily follow correct grammatical structure. Thank you for watching. In conclusion, this app can help with conducting text analytics in Splunk. Text analytics can be difficult, certainly not an exact science, especially when using unsupervised learning, and can be a slow process depending on the amount of text you are dealing with. Though with my support ticket example, we may have found a couple of clusters worthy of a new category. For references for this app, this video, this project, and associated blog, please see my references page on GitHub. Thank you.